The CAP theorem is an important database concept to understand in system design interviews. CAP stands for consistency, availability, and partition tolerance, hence the name CAP theorem. Consistency refers to all users being able to see the same data at the same time. Availability means that the system is always available for reads or writes even with node failures. And partition tolerance means that the system continues to function even if communication fails between nodes. The theorem states only two of these three properties can be ensured in a distributed system. In system design, an assumption we make is that network partitions will happen. So to offer any kind of reliable service, partition tolerance is necessary. So you can't choose to forfeit the P in CAP. That leaves us to make a trade-off between ensuring consistency or availability. Let's first talk about consistency. Consistency is the property that after a write is sent to a database, all read requests sent to any node should return that updated data. Imagine a scenario where there's a network partition. In this case, both node A and node B would reject any write requests sent to them. This would ensure that the state of the data of the two nodes are the same. Otherwise, only node A would have the updated data, and node B would have stale data. Sometimes you'll hear the term strong consistency. The consistency in CAP theorem does not necessarily refer to strong consistency. In a strongly consistent database, if data is written and then immediately read after, in theory, it should always return the updated data. However, in a distributed system, network communication doesn't happen instantly since nodes are physically separated from one another, and transferring data requires some amount of time. This is why it's not possible to have a perfect, strongly consistent distributed database. In the real world, when we talk about databases that prioritize consistency, we usually refer to databases that are eventually consistent, with a very short, unnoticeable lag time between nodes. So, to summarize again, consistency in the CAP theorem means that all users would be able to see the same data at the same time. Now, let's talk about availability. In a database that prioritizes availability, it's acceptable to have inconsistent data across nodes, where one node may contain stale data and another has the more recent data. Availability means that we prioritize nodes to successfully complete requests sent to them. Available databases also tend to have eventual consistency, which means that after some amount of time when the network partition is resolved, all nodes will eventually sync with one another to have the same updated data. In this case, node A will receive the update first, and after some time, node B will be updated as well. Now, let's think, when should consistency or availability be prioritized? If you're working with data that needs to be up to date, then you'd want to prioritize consistency. On the other hand, if it's okay that the query data can be slightly out of date, then storing it in an available database may be a better choice. Let's check out some examples for a better understanding. Imagine you're building an app like Amazon, where shoppers can browse a catalog of products and purchase them if they're in stock. You want to make sure that products are actually in stock, or you'd have to refund the shoppers for unavailable items. Should your database that stores product information prioritize consistency or availability? Here, you should choose consistency. In the case of a network partition where nodes can't sync with one another, you'd rather not allow any shoppers to purchase any products than have two or more shoppers purchase the same product when there's only one item available. An available database would allow for the latter, and then at least one of the shoppers would have to have their order canceled and refunded. Let's imagine another scenario with the same Amazon-esque product. Let's say a PM decides that it's much more cost-effective to refund shoppers for unavailable items rather than to show them as out of stock during a network failure. In this case, you'd want to prioritize availability, since canceling and refunding orders will be preferable to not allowing any shoppers to purchase the product at all during a network failure. Now, notice that only write requests were discussed here. This is because read requests don't affect the state of the data and don't require resyncing between nodes. Read requests are typically fine during network partitions for both consistent and available databases.